Chapter 1, Appendix. We can prove the following general proposition related to exercise 5. We can use it for an alternative solution of the exercises 6 and 7, and it has other applications in upcoming chapters. For the video, A will be set as big. Lemma. Let big be a non-empty subset of R that is bounded above, such that A is greater than 0, for all A in big. And if C is greater than 0, then 1. Supremum C big equals C supremum big. 2. Infimum big inverse equals 1 over supremum big, where C big equals CA such that A is in big, and big inverse equals A inverse A in big. Proof 1. 1. Supremum C big equals C supremum big. Let alpha equals supremum big, then alpha greater than or equal to A for all A in big. Since C is greater than 0, then C alpha greater than or equal to CA for all A in big. Hence, C alpha is an upper bound of C big, and C alpha greater than or equal to supremum C big. Suppose that supremum C big less than C alpha. Since C greater than 0, then supremum C big over C less than alpha. By definition of supremum, there exists A in big such that supremum C big over C less than A less than or equal to alpha. From here we have a contradiction. Supremum C big less than CA. Thus, supremum C big equals C supremum big. Here is a picture. Geometrically, the set C big is the homothetic image of the set A in the homothety with the center 0 and ratio C. Two figures are homothetic if they are related by an expansion or geometric contraction. Points to the right of big, upper bounds of big, are converted to points to the right of C big, upper bounds of C big. Proof 2. 2. Infimum big inverse equals 1 over supremum big. Let alpha be supremum of big, then alpha greater than or equal to A for all A in big. Thus, alpha inverse less than or equal to A inverse for all A in big. Hence, alpha inverse is a lower bound of big inverse, and alpha inverse less than or equal to infimum big inverse. Now, suppose alpha inverse less than infimum big inverse. Then there is R in Q such that for all A in big, alpha inverse less than R less than infimum big inverse less than or equal to A inverse. That is, for all A in big, alpha inverse less than R less than A inverse. By taking reciprocals for all A in big, A less than R inverse less than alpha, then alpha is not the supremum of big, which is a contradiction. Hence, alpha inverse equals infimum big inverse. Here is a picture. Geometrically, the set big inverse is the image of the set big in inversion. Since the inversion changes the orientation of the line, then points to the right of big, upper bounds of big, are converted to points to the left of big inverse, lower bounds of big inverse. Thanks for watching.